Okay.
Okay.
Well, good afternoon, everyone. So today, CASTIEL 2 or Package 4 is very glad to welcome Samir Ben Shaban from POP 3, the CoE POP 3. So today, Samir will present you the activities and the potential services of POP 3 and how there could be a potential of fruitful interactions between the NCCs, the COECs, and POP 3. And let's dive directly into the topic. Samir, the floor is yours.
Thank you, Marie-Françoise. Welcome, everybody. Thank you for attending this webinar, presenting the POP3 activities and services. So, POP3 started last January and succeeded to POP1, who took place between 2015 and 2018, and POP2, who took place between December 2018 and May 2022. POP3 is one of the centers of excellence in HPC. POP means performance optimization and productivity. So improving the performance of parallel code seems straightforward, but due to the complexity of codes and ever-evolving HPC technologies, it's often difficult to know what is the best approach to improving the performance of a given application. And as a result, the task of performance optimization becomes a trial and error process. A specific methodology was set up and developed by POP experts and uses metrics to solve this type of problem. POP offers free services to academic and industrial users in the European Union, helping them understand how their applications interact with their hardware environment. So two main services are offered. These services are, the first one is performance assessment, and the second one, what we call now second level service, includes several types of services. I will detail this later. The overall objective to improve performance and thus reduce the calculation times is the main objective of POP CoE. It's also aims to perform more complex calculations, improve calculation accuracy by considering thinner, more precise models with constant costs, and possibly save energy. These services are aimed at a range of European players, from software developers in industry and academia to code vendors and hardware infrastructure operators, such as the computing centers. These services cut across all areas or application platforms and scales. 8 partners are involved in POP CoE. We have BSC, Barcelona Supercomputing Center, which is the leader of the CoE, Jülich Computing Center, HLRS, the University of Aachen, the University of Versailles Saint-Quentin-en-Yvelines, IT4I, which is a computing center in the Czech Republic, INSEC, which is a computing center in Portugal, and Teratech. These partners form a pool of experienced team with an excellence in performance tools and tuning, excellence in programming models and practices, and with a research and development background and proven commitment in applications to real academic and industrial use cases. So what are the motivation for this activity of POP CoE, and why people can apply for these services? So first of all, the complexity of codes and machines and their evolution mean that on the one hand, there is a lack of quantified understanding of the actual behavior of the code, And on the other hand, it's difficult to choose a direction for a productive redesign of the code to improve its performance. So let's point out the importance of maximizing the efficiency of a parallelized applications in intensive computing and optimizing development efforts. This is, of course, in addition to the performance gains generally achieved after this type of optimization and the possible financial gains by reducing calculations times. POP focuses on optimizing parallel applications with particular emphasis on MPI and OpenMP, but also encompassing a broader range of programming languages such as CUDA, OpenCL, OpenACC, and Python. The process to subscribe or to benefit from these services. So, first of all, code developers should take advantage of the services offered by CoE POP, the CoE POP. And to benefit from these services, you can apply they can apply, or developers or users of applications can apply using the form following the link here, and filling in an initial questionnaire concerning the code, some information about the code, the language in which is developed the code, the method of parallelization, etc. And you submit this with the link. If your code is selected by the management team, a POP expert will be appointed to carry out the various tasks like installation of tracing tools, data recovery and analysis of the data, etc., and will be your main contact. As I announced earlier, two main services are offered by the POP Center of Excellence. These services are the first one, performance assessment. So this corresponds to an initial analysis measuring a range of performance metrics to assess quality of performance and identify the issues affecting performance at the customer site. If needed, this task undertakes further performance evaluations to identify the root causes of the issues found and quantify approaches to address them. They give recommendations to the user to correct these efficiency issues. So this normally takes an average between 1 to 3 months. It depends on the code, the complexity of the code, etc. In POP3, we have a second level service. In POP2, we have what we call proof of concept, but we replaced it, but extended this with a second level service. So the second level service may follow after conclusion of initial performance assessment and can include several types of operations and services. The first of all, the proof of concept, with the objective to explore the potential benefit of proposed optimization by applying them to select the regions of the applications. A service which is called correctness check, which will evaluate the correctness of hybrid MPI plus OpenMP applications. A new service which is called energy efficiency study, which will investigate improvements of energy consumption and or efficiency. And a last service, which is called advisory study, with an ongoing consultancy for customers that choose to implement the proposed optimization on their own. The average effort or duration of this second level service varies between 3 and 6 months according to the complexity of the code and to the work to be done. POP offers also a blog, newsletter, presentations, and webinars to help the users learn about our methodology and tools for performance analysis. POP is also present on social networks through Twitter, LinkedIn, and YouTube. You can also find all the information about the POP CoE on the project website. We can consider also training courses as a service. So POP team offer free training and self-study resources to support users. POP training sessions focus essentially on the challenges of HPC performance analysis, how POP metrics can help you understand application performance, how training about calculating POP metrics for you, your HPC applications, training on available POP tools and their installation, and trainings about capturing and analyzing performance data with POP tools. The customer or the user that can benefit from these services can be code developers with assessment or detailed actual. They can conduct assessment or detailed actual behavior of the code. They can get suggested or most productive directions to refactor their code. The users can also be the sample user of the application. We can achieve assessment of the performance and specific production conditions with recommendation of possible improvements, modifying environment setup, and with a need to interact with the code developer provider in this case. The user or the customer can infrastructure operator, and they can benefit from the assessment to achieve performance in production conditions, to study also possible improvements from modifying environment setup, and to get information for type, computer, and time allocation processes, and to benefit also from training of support staff. Finally, software vendors can benefit from these services by doing or performing benchmarking, by supporting their customer, and by dimensioning and designing systems for their software. Let's now present some statistics issued from the results obtained during POP2 and POP1 periods. So during POP1 and POP2, we have more than 250 services provided since October 2015 across all domains. The domains can be engineering, earth and atmospheric science, physics, biology, genetics. We'll have a detailed statistics about that in the next slide. This represents almost one service per week. So the outreach with the outreach activity, we had more than 20 trainings and workshops available and performed. We have 19 webinars available on the POP CoE website. So this figure here shows the distribution of services across the different types of players. So we have essentially academics, research institutes. We have also SMEs, which represent 21% of the services delivered, and 6% of large companies. Here is some statistics about the provided services during POP2. So the first figure highlights on the top, on the left, on top left, highlights the sectors that benefited from POP2 services. We can observe that engineering and atmosphere and earth science are the best represented sectors, with the respectively 30 and 28% of the delivered services. The programming languages of the applications here considered vary from C, C++, Fortran, but more and more code is being developed in Python or combination of these languages, all these languages, as shown in this figure. The last figure on the right shows the programming models used in the codes analyzed, the programming models for parallelization. Here we find essentially MPI and its various variants. The main observed causes of inefficiency in the applications analyzed are essentially load balance and algorithmic problems related to computation. The figure on the right shows the inefficiency statistics by type of parallelization. On this slide, I'd like to give some examples of return on investment. So the first example concerns a proof of concept that resulted in 72% acceleration of the code. This code runs on the Archer machine at the University Computing Center in the UK. The changes made to the code have resulted in a potential saving of more than 15 euros per calculation, and an annual reduction in calculation cost of around 56,000 euros. The second example concerns a performance analysis leading to recommendations for changing changes to the code or changing the programming of the code. The cost of these modifications is estimated at 2,000 euro, and the corresponding reduction in calculation time is of 62%, is of almost 62%, which corresponds to an annual reduction in calculation costs of more than 12,000 euro, and therefore return on investment of more than 600%. This slide presents the results of the analysis of a CFD code. It's a parallelized code written in Fortran and using OpenMP for parallelization algorithm. The POP experts carried out a performance assessment of the code, followed by a proof of concept. The software runs on a machine on the Mare Nostrum platform at the BSc Supercomputing Center. This machine is a machine with dual Intel Xeon Platinum with 48 core nodes. For this code, the POP experts did not have access for the performance analysis, have not access to the software source code. Only the executable was used to analyze the code performance. The analysis was performed with a scaling up to 45 threads. The tools used in this case were Extrait and Paraver, Vtune, and Macau. The table shows the POP metrics and submetrics obtained for this code. We can observe that the overall efficiency drops dramatically when we go from 1 to 45 threads. This overall efficiency is calculated from the parallelization efficiency and the computational efficiency. These POP metrics clearly show the causes of the inefficiency. For example, there is a certain loss of efficiency due to an imbalance in the OpenMP loops. We also observe poor computational scaling caused by poor IPC or instruction per cycle scaling, which represents a major bottleneck. Following this performance analysis, the POP experts produced a proof of concept to suggest modification to the code to improve its performance. This proof of concept enabled POP experts to provide the user with practical help in modifying the code to improve the application's performance. For the assessment, we only had the executable for the POC part. Part of the code was extracted and made available. The aim being to improve the performance of the extracted kernel by resolving the problems identified in the performance analysis. POP experts focused on OpenMP efficiency and IPC scaling. In this example, OpenMP was used. The use of OpenMP collapse improved load balancing in the OpenMP. So, following these modifications, the modified code is 1.6 times faster on one thread. And due to the reduced number of instructions, the modified code shows better scaling and speed up of more than 16 on 45 threads compared with one thread. The improvement in scaling is due to better computation scaling caused by an improvement in the number of instructions per cycle. As a result, the modified code is globally more than 2 times faster than the original on 45 threads. Now, this example demonstrates the capabilities of POP tools for calculations on large machines. So the largest experiment carried out by POP expert, which is here on the left, concerns Neckbone, which is a software application that solves the standard Poisson equation using conjugate gradient iteration with a sample of our spectral multigrid element preconditioner. The analysis of this application was carried out on Jülich GeoQueen system using more than 28,000 multiplied by 64 threads. This means more than 1,800,000 threads. This is compared to the largest experiment carried out by external user, which is RICAN, a Japanese research institute, with the help of Jülich partners, for its NEST neural simulation technology application on K computer machines using almost more than 600,000 threads. So you see here that the scaling of the machines used by POP experts can be very, very large machines up to the exascale machines. So another analysis was carried out on the open source code ML, which is the lattice Boltzmann code for simulating large-scale three-dimensional fluid flow in complex sparse geometries. This code is being developed by CompuMed, a COE funded under the ACE 2020 framework. The POP performance analysis is being carried out on the super petascale machine or system supercomputer at the Leibniz Supercomputing Center with more than 300,000 MPI processes. Here you can find additional success stories which are available on the POP web page. We invite you to take a look to these success stories. To sum up, we can conclude that POP metrics can be used to build a quantitative picture of application behavior, rapidly diagnose performance problems in parallel codes, identify strategic directions for code refactoring. The metrics used by POP experts or that users can use also. Can be used for MPI, OpenMP, and hybrid parallelized codes. POP works for all application domains, all platforms, all scales, with academic and industrial European customers, including code developers, code users, HPC service providers. The POP CoE promotes best practices in parallel programming and encourage a systematic approach to performance optimization, and facilitates and invests in the training of HPC experts. What do we expect from NCCs? What can be a collaboration with the NCCs is firstly to promote the services provided by POP CoE, which are free services to the users. We need to identify industrial users, mainly SMEs, who can benefit from these services. This is very, very important for the HPC. And to relay announcements for training courses and seminars. So for more information, you can visit our website or contact me by email. Thank you for your attention. I'm ready to answer your questions if you have questions. Thank you.
Okay, thank you very much, Samir. Before continuing with the question, let me just stop the recording.